This is my dream precision metal lathe. Gavin Gear here for makingwithmetal.com. This is the Precision Matthews PM-1440GT lathe. In this video, I'm going to give you the most in-depth source of information about this lathe. I'm going to demonstrate every feature, talk about every specification, turn every knob. I'm going to give you the next best thing to you being right here running this lathe. I'm also going to talk about some of the upgrades that I performed and some of the minor feedback that I've given to Precision Matthews about things that I've either improved or would like for them to improve. So buckle up your seatbelt, check out the chapter markers in the video. This is going to be about this lathe, and I will do some demos, but I have good news. I'm not going to teach you how to run a lathe in this video. I have a whole multi-year series, the fundamentals of lathe, that's coming up, and it's going to be featuring this Precision Matthews PM-1440GT. In addition to that, I will also be publishing a fundamentals of mill video featuring my Precision Matthews PM-949 TV. I have partnered with Precision Matthews to bring you this content. If you want to know more about what that means, click on the link in the video description. This is awesome. I am totally happy. I've built 3 custom rifles with this lathe. I've built precision tooling. I've turned ABS. I've turned Delrin, aluminum, multiple alloys. I've turned carbon steel. I've turned stainless steel. I've, over the last 6 months, gotten a lot of experience, and now is the time to share with you the story of the Precision Matthews PM-1440GT. How did I end up with this lathe? Okay, so I started machining back in the 80s with Grandpa, and he really inspired me to want to do my own work. I later studied mechanical engineering, and in the curriculum I did more machining, learned more of the theory, learned more about metallurgy and everything. Then eventually I decided I needed my own metal lathe. Great choice! Everybody needs a metal lathe. I went through several American machines. I started with a South Bend and then upgraded to a Logan, which was really a great upgrade from a 10-inch machine to an 11-inch machine, 11 by 36. And then I ended up inheriting Grandpa's South Bend lathe. Love these machines. But when you want to do ultra precision work and you want to have more capacity, there were some things that I was really looking for. The first was ultra precision. I knew that when I'm building a custom rifle and a 1/10 of a 1,000th of an inch matters, I needed something that was super tight and super precise. Speeds and power and capacity was another thing. I wanted 2-inch through spindle capacity. I wanted at least 2 horsepower. I wanted a geared head design so that it had a wide range of speeds that would be more appropriate for carbide tooling, which can handle faster feeds and speeds. And I also wanted accessories, options, features. My Logan lathe was great, but I never had a good steady rest for it. I didn't have a micrometer carriage stop, and there were some other things that I had to build that just, it wasn't quite where I wanted it to be. And this is where, talking with my gunsmithing mentor, Gordy Gritters, I decided I wanted a new machine. This is a big investment. And I also decided I wanted a Taiwanese machine. If you're looking at a new metal lathe and you're not spending $100,000 or more, it's likely going to be made in China or it's going to be made in Taiwan. And a lot of guys do great work on the Chinese-made equipment. Usually there's some tweaks that you've got to do, some kind of fine points, rough edges that you've got to sand off. The Taiwanese machinery is the next step up. You'll see later in this video, I'm going to give you a full guided tour. I'm also going to give you an evaluation of the precision of the machine. You'll see firsthand. This is an ultra precision machine. This thing runs nice. It's got a nice finish. It's built well. This is a machine. I know 2 custom rifle builders that use this machine as well. Travis Riddell from Arbros and Bill Maher from rifleshooter.com. And there's a reason. This is the only Taiwanese made machine with a 2-inch through spindle and a short spindle, 15.5 inches. And this machine performs well. It's also available at a very good price point considering the level of precision and the features. And that's why I partnered with Precision Matthews, is because I knew that this was the machine that I wanted, and I also knew that Precision Matthews is different because of Matt. Matt is very involved with his customers. He's very involved online. He's flying personally over to the factories overseas to make sure that everything is right. He's got exclusive deals on things like this Taiwanese 2-inch through spindle capacity machine, and that is how I ended up where I am at here. So what we're going to do is I'm going to start with the guided tour, and then I will run through some demo scenarios. We'll test the precision, we'll talk about accessories, and then wrap things up. Let's get going. Okay, let's start down here at the bottom. I got the cast iron leveling feet, which work great. Rolled the lathe into place on 3/4 inch black pipe, tightened the bolts down, lifted the lathe off of the pipes. Super convenient way to move the machine. The base itself is included with the lathe. The lathe comes in a crate, bolted down to the base, and I absolutely love that. You just use a crane or a hoist to lift the lathe off of the pallet, and then I put it on pipes, rolled it into place. It is pretty much ready to go, which is great. So the stand is made out of steel. It's very solid. It's nicely painted with epoxy paint. It's this dark gray finish here. There's a large chip tray. I really like how this is arranged because the entire chip tray comes out really easily to dump the contents into a trash can, and then it just slides right back in place. There's a drain here where your coolant, if you're using your coolant circulation system, is going to drain right back into the reservoir where the pump is also located. That's on the right side here in the stand, in the base. On the left-hand side, towards the back, you've got the electrical panel. And the electrical for the PM-1440GT is laid out very immaculately, and in the owner's manual, you'll find exactly where to hook up the AC power. This is 240-volt single phase. There's also the option to have 3-phase power. Some people prefer a 3-phase motor for a little bit better surface finish under certain conditions. And then around the end here, we've got the serial tag. Let's move our way up. Okay, let's start on the headstock side. So here we've got the side cover. It comes off with these 2 thumb screws here. And then I've actually enlarged the opening for the outboard side of the spindle to accommodate this custom outboard spider that I machined. This is great for when you need to support longer work, or if you have a rifle barrel that needs to be precisely aligned prior to the machining and chambering. I'll have a separate video on that upgrade and the making of the spider. It's got a pinch clamp design, so you've got 1 bolt to take it off, non-marring for the outboard spindle section. Very nice. Let's take a look at the main controls next. Okay, so starting at the top, we've got the spindle speed control levers, low, medium, and high ranges, 4 speeds per range, yields 12 speeds total from 50 RPM on the low end, which is great for something like power tapping, all the way up to 2,000 RPM, which would be great for things like polishing and sanding or really high speed turning. Very quick to set speeds, which I absolutely love. Then we've got the feed direction control knob. And so pointing to the left, we've got the carriage power feeding to the left and the cross slide feeding in. And if we switch that to the right, the carriage will go to the right and the cross slide will power feed back out towards you. There's the coolant pump motor. You just turn that on and then meter your coolant with the ball valve. This lamp here tells you if there's power going to the lathe, and I just have a panel right next to the lathe and flip my breaker off at the end of the day. We've got the jog button, which is just going to turn the spindle based on how long we hold in the button there, and then the panic stop button, which at any time we just hit that, everything's going to stop. You're going to want to have your foot next to the brake as well. It's always a good idea to use the brake when you need to quickly stop the spindle. Down here, we've got our feed controls, and there's 2 types of feeds you want to think about. When you engage power feeds, that's going to correspond to very fine feeds per spindle revolution, either for the carriage or for the cross slide. And then when you're threading, that has to do with when you engage the half nuts, which is usually a faster speed. So you're going to want to look at how much feed you want per spindle revolution or how many threads per inch you want, and that is going to indicate which lever selection you pick and which knob combination you pick as well. I will make a quick note that the lathe comes with change gears. And usually, I haven't had to change these change gears yet, but if you're going from inch to metric or for certain combinations, you're going to want to look at the number of teeth for the gear and confirm that you've got the right gears set. So that's one little note on this. And from here, we're going to move over to the spindle. Here we see the monster 2-inch through spindle capacity. I will note that the lathe comes with a sleeve. This is a spindle reducing sleeve. That's Morse taper 5.5 on the outside. Push that in, and then you can take a Morse taper 3 accessory and put that right into the spindle reducing sleeve. So if we've got a faceplate and we want to turn between centers, this is a very easy way that we can accomplish that. When we're done, we can slide a rod in from the other side and just easily knock it out. Let's talk about the bed and ways real quick. So the bed is super heavy, it's cast iron, and it's got induction hardened and ground ways, which are going to last a long time. There is a removable gap bed here. You remove 4 bolts. That comes out and that gives you 22.25 inches swing over the gap, which is nice. With it in place, it's going to operate just as normal. You're going to get the carriage right up close to the spindle. We've got 3 rods here. We've got the feed rod for threading, we've got the feed rod for power feeds, and then we've got the motor control rod. All right, so let's take a look at the carriage starting on top here. We've got the coolant nozzle and the coolant nozzle valve. This is going to follow the tooling. We can easily position where we want the coolant to drop to. You get that back out of the way, no problem. And then on the top of the carriage, we have the cross slide and we have the compound slide. These both have tapered gibs. They're both precision ground on the top, so we can use magnetic indicators on these. They've got ball oilers. I use Mobile Vactra number 2 in an oiling can like so. You just depress the little ball bearing. It's got a spring behind it, and apply your oil. Very easy way to lubricate this particular machine. Since they have tapered gibs, the compound and the cross slide are going to be tight, but you can get them just at the right level of precision where they're not going to bind, but they're also not going to rattle, which is going to enhance the precision of your machining. There's also a carriage lock over here, which I've fashioned a custom handle and Allen key for. I like this because I just rotate it a little bit less than 90 degrees to lock the carriage. If we're facing or for parting, that's going to be an important thing to do to preserve its positioning. We've also got a threading dial, which is great because that allows us to engage and disengage the half nuts so that we can take multiple passes with precision without having to keep those half nuts engaged. Let's look at the apron. So on the apron, we have the crank for carriage position, we have the power feed control lever, the half nut engagement lever, and the motor control lever. Let's see how these work. So if we go up, that's going to run the spindle in reverse. The middle is off, and down is forward. If we want longitudinal feed, we pull the plunger out and pull it up. If we want cross feed, we push the plunger in and push it down. On the headstock controls, we can change the directions of these respective power feeds. Let's set our threading for 24 threads per inch. We're going to need BC and then follow the 24 up. We're going to need PX. Let's make those adjustments. So first with the knobs, B, C, and then with the levers, P helps to turn the spindle while you're doing this so that the gears will mesh, and then X, this is going to be 24 threads per inch. Now when we turn on the lathe again, we'll see that the feed rod for threading is turning, and we can engage the half nuts aligned with one of these numbers. Starting at the back of the tailstock, we have 2 levers, a lock for the quill and the clamp for the ways. The tailstock has 4 inches of quill travel. It's got an internal taper of Morse taper 3. It's got this flat top, which is really nice when you want to run an indicator holder to monitor depth. I use this for rifle barrel chambering all the time. It's got a ball oiler for lubrication. It's got inch and metric graduations on the collar for monitoring depth. And it also has I'm gonna lock this, has a tang lock so that things like your drill chuck will not rotate when you're drilling. Very nice features, really solidly put together. All right, let's talk core tooling and accessories before we go any further. Some of this was included with the lathe base package, some of it was a part of the preferred package, and some of these items I added. You're going to want to check the web page for the PM-1440GT. It has the preferred package details and the base package details outlined there. The lathe comes with the toolbox. Inside were things like this Allen key set, a combo metric 14mm and 17mm wrench, and some of the other items shown here. There is the manual on CD, the parts list and operator's manual, print version. And then we've got spindle accessories and chucks. These are all D15, they direct mount to the spindle. I've got the Precision 8-inch 4-jaw chuck. This is available from Precision Matthews separately. Really great for precision work and for rifle barrel chambering and machining. Precision 3-jaw chuck. This is the Auto Strong. This was a part of the preferred package when I bought the lathe. This is a great piece of gear. I've had chucks that couldn't hold 5/1000ths concentricity. This has under 1/1000th of an inch, right around 1/1000th of an inch. Very nice chuck. This is something I got separately from Pratt Bernard Atlas. This is the PB23 Quickie hand wheel 5C collet chuck. In my opinion, one of the most important things to have for a lathe is a 5C or other collet setup. Collets grip better, they hold concentricity better, and they're good for gripping delicate parts and delicate features like threaded sections where you want to turn down a shoulder on a different section of a round bar material. Okay, and then we've got the faceplate. The faceplate is great for turning between centers or for bolting down items that are asymmetrical and difficult to chuck in an actual chuck. This was a part of the preferred package when I bought the lathe. This is a custom tooling fixture that I made to turn down multiple sections to test for alignment between the tailstock and the headstock. The lathe comes with a really nice follow rest and a really nice steady rest. These are cast iron. They've got steel knobs. They've got brass tips. They're nicely epoxy painted like the lathe is. It's very durable paint. And then, you know, the follow rest is kind of built the same way with the same construction and features. There's set screws to preserve those positions, and they're just very good accessories to have. In a like manner, micrometer carriage stop. This works with the feed rod clutch on the PM-1440GT so that the carriage can basically hit the stop, the feed rod clutch engages, and you'll turn a shoulder or a feature to the same exact spot each time the carriage stops. The lathe comes with a complete set of change gears for some of the different feed rates and the different threading options that you have. I have not had to change these. I built this custom rack out of steel so that I can keep these gears easily organized and so that I can find the gear that I need when the need arises to use those. The lathe comes with two dead centers, one with a carbide tip and one without. So you use the carbide tip on the side that would spin, and then the high-speed steel and precision ground on the other side and the spindle side. These are the boxes that those dead centers came in. The lathe comes with a turret-style tool post. I opted to upgrade to an Aloris clone quick change tool post, which I'll show you later in the video. And then we have the reducer sleeve for the spindle, which I showed when I did an overview of the spindle. Morse taper 5.5 on the outside, Morse taper 3 on the inside. This covers 90% of the scenarios and all of the basic bases that you're going to need for precision work. Let's continue the tour. So those are the basic parts of the lathe. The next part of the tour is to do some machining. Okay, let's go ahead and mount a chuck so that we can do some demo turning. Now, I will note here, I have a number 1 stamped on the spindle and a number 1 stamped on my chuck. These are alignment marks where I've confirmed the precision of the alignment of the chuck. So what I usually do is I give these a quick tighten all the way around. 2, 3, 4, 5, and 6. Now I give them a final tightening all the way around. 1, 2, 3, 4, 5, 6, and then I confirm, yep, we're really tight on the ones that have already been double tightened. Okay, now we can mount some material. I've got some aluminum tubing here that should be good for a demo. Just gonna chuck this up, and we'll turn a bit of a shoulder on here. So let's go with a feed rate of 3.6 thousandths per revolution. We need BC. We're already on BC here, and our lever positions need to be IX. We're already on X down here, so we're going to move over to I, and that should do. So we'll just start the spindle, get our tool into position, crank her in a little bit, and then engage the power feed. Take another pass, take a finer cut. Okay, let's do a power parting procedure. Very nice. Okay, let's do a heavier cut on some steel to test the rigidity of this lathe. Some larger diameter material. It's just some steel round bar I had laying around. Okay. And I'm going to slow the spindle down just a little bit. Put a heavy carbide tool on there. Okay, we'll call that 0. Let's take 200 thousandths. How about that? Taking off almost a quarter of an inch here of material. As you can see, the lathe is not slowing down even a bit. Okay, after multiple passes there, we're going to crank the speed up a little bit. Take kind of a nice finishing pass here. I'm just going to go in a couple thousandths of an inch. Get a nice fine cut. Why don't we face off the end there? We've got kind of a rough finish going on that side. Okay, so I'm gonna go ahead and change our speed once again. Change our feed direction. We're gonna face from the inside out. Just take a very light cut there. Okay, so I'm going to go ahead and clamp the carriage. Engage our power feed. Take one more pass, clean that up a little bit. Give that a little touch up with a file to break the edge there. Okay, let's do a quick threading demo. I've got my levers set for 24 threads per inch. I rechecked and turned down to section on this aluminum tube that we've got. We're going to slow that down a little bit. That should be good. And what I like to do is I just get my tip touching and then I zero out the x-axis on the DRO. This is going to be the point I'll always return to, and then I'll infeed with the compound. So let's give it about 5 thousandths at a 29-degree angle, and then we can go ahead and engage the half nuts on any of the tick marks based on this thread pitch. Okay, so back, zero out the DRO. We're going to infeed, say another, let's do 7 this time. Wait for a dash. We'll go ahead and just repeat this process until we're at exactly the right thread depth. And of course, one of the things we'll do frequently on a lathe is drilling. Drilling and boring so that we can enlarge holes, we can precisely align holes by removing any drilling inaccuracy. So, I'm going to bring this tailstock in. Go ahead and do some drilling here. And we know that's not going to be perfectly accurate. So we can follow that up with the boring bar. Now we have a hole that is both the exact diameter that we want and is running perfectly concentric with our part. All right, now that we've done some quick machining demos, let's do a few tests that's going to quantify the precision and alignment for this lathe. The first step will establish the alignment precision for the headstock, and that's to turn a cylinder. We measure in 2 points, and we can see how precisely aligned the axis of the spindle is with the lathes. Okay, so to quantify the precision of our alignment, we're going to zero out over here, go about 4 inches down, take another diameter reading, and we're at 3/10,000ths of an inch over 4 inches. That's a great result. Another really critical evaluation criteria is spindle runout. I've removed the chuck and shifted the headstock gears into neutral, and I've got a 10,000th indicator here. What we're going to do is run this in until it's deflected on the inside of the taper, and then we're going to really slowly rotate the spindle, observing. And I see basically no needle movement there, just a little bit of fluctuation, most likely just due to the deflection of the needle from friction sliding sideways. Pretty much dead on. This test will evaluate parallelism between the quill and the lathes. I'm just going to bring this 10,000th indicator forward so that it just contacts the quill, and then we'll run it along the quill for, say, a couple inches. So there we are. We're at a little bit beside zero there, and we're within, I'd say, over 2 inches. We're within about 1/10,000th of an inch. That's a great result. Okay, now we can check the alignment of the headstock and the tailstock. In order to accomplish this, there's a couple different kinds of tools you can use. What I have here is a test rod being driven by a lathe dog. The lathe dog is actually too small to go into the slots, so I'm using these recessed holes here, which is fine. We just need something to turn the test bar. I've got the reducing sleeve in the spindle. I've got a Morse taper 3 dead center here, and then I've got a Morse taper 3 dead center on the tailstock end. I put a little oil on there, and what we do is we turn the two sections while they're being turned between centers, and if they're turned to the same diameter, then we know that the tailstock is in good alignment with the headstock. Okay, so just like with our turning a cylinder test, we're going to take 2 diameters, one here, make sure everything is perfectly square. Okay, 9999, and over here, 99985. So we're basically within 1/10,000th of an inch. Amazing. One of the things I've spent a lot of time on with this lathe and actually enjoyed quite a bit is getting everything organized just the way I want it and adding all the accessories and fine touches. Let me show you some of the stuff that I've done. The first thing was some trays, and this tray is something that I made from angle iron, sheet metal, and some stair tread material, and I attached it over the top of the headstock here. Now, one of the things that I found was there was a little sort of depression on the top cast into the casting, but I didn't quite have enough room for all the tools that I wanted to put on the lathe, and I wanted to have a nice flat surface with this box around the edge to keep tooling from falling off the edge. I've also got over here storage for keys. This is the D15 key for these pin features. And then my 4-jaw chuck has another key. And then this is for tightening and loosening the pinch clamp on the outboard spider. Let's go to the splash guard tool tray. Okay, I absolutely love this splash guard tool tray. It gives me room to put indicator holders, all of the tool blocks for my quick change tool post. I've got parting blades, boring bars, turning tools, all sorts of stuff set up and ready to go. I've got a small container that I made a while back with machining oil to brush onto parts while I'm machining. I can magnetically attach things like this Mighty Mag indicator holder for the tailstock. I've got my oil up here, center drills, and then I also made this rack over here. This in my book is another essential. It's just a wood strip with some cross holes drilled through, mounted to the tray. It's got Morse taper 3 holes drilled in it. I made a custom spade bit at approximately Morse taper 3 taper. I've got all of my frequently used Morse taper 3 accessories here: die holder, live center, floating reamer holder, dead centers. And this means that right next to the tailstock, I can just grab a tool and put it in just the way it should be. Over just off the end of the lathe, just below my panel, I've got a complete 5C collet rack that I built for my Logan, and I kept it. This has got all the way from 1/16 to 1 1/16 by 32nd of an inch, and it's also a handy decimal conversion chart. Just pop the collet out the top, grab it, put it into the collet chuck. Here's the Atlas 5C collet chuck on the lathe. It's very handy. You just step on the brake. That means you can quickly turn this wheel, insert your material, clamp it down, and then you're off and running, ready to do some machining. Very handy. Another custom addition I've put together for the lathe is I welded these T-handle wrenches. There's 3 of them. The first 2 are for the tool block adjustments. You've got the tool block set screws. You've got this post screw, and what's nice about this is it works with this T-handle here, which is a socket, and I can get this Allen key through, and I can adjust the tightness of the nut without having the post back out, because those posts do want to back out. That is a super cool tool. And then we've got the compound clamp nut extended T-handle wrench. So I can go all the way down below this block and not have to fiddle around with the right angle Allen key. I can quickly make my compound adjustment, get it back exactly where I want it at 29 degrees, usually. Clamp those down very quick, and it's right up here on my headstock tray. And this is where I organize all of the tooling. This is just a rolling tool cart with a maple top from Home Depot. Nothing special, but it's got ball bearing slides. I've got pretty much all my cutting tools and some of the lathe accessories here. I've got files right here next to the lathe where I need them for quick access. And then down in the bottom, there's these nice ball bearing deep drawers where I put all of the heavy chucks and stuff like that. Very, very handy. I've even got a spot for the steady rest and the follow rest. Everything is labeled just how it should be. So there you have it, the complete guided tour of my Precision Matthews PM-1440GT metal lathe. If you're in the market for precision metal lathe, I hope this answered all of your questions. If not, please drop a comment. What did you think of this lathe and the accessories and all of the tooling that I put together? Please drop a comment. And don't forget, I've got fundamentals of lathe and fundamentals of mill. We're going to start at the very beginning and work our way up through some really awesome advanced topics. Make sure you're subscribed with notifications. And if you like this video, please give it a thumbs up. Until next time, happy machining, and happy metalworking.